Hi everyone, welcome to the PrestoCon and welcome to today's Presto Pinot Datalake segment reader session. My name is Mingjia Han and I'm a software engineer from Uber. So to begin with, I just want to give you a brief introduction about Pinot. So Pinot is a real-time distributed online analytical processing data store designed to handle low latency queries on large-scale data. It supports high throughput ingestion from various data sources and provided a flexible, scalable architecture for real-time and batch data analysis. Since 2023, there are more and more use cases onboarded to Pinot in Uber. So right now we have over 6,000 tables with the medium 7 days data retention. And to support this, we have 800 Pinot hosts. And there are 2 petabytes data on the host and also 2 petabyte data on HDFS. So HDFS is as a deep store copies for Apache Pinot, and it stores all the data which appear on the Pinot server. Since we have one more use cases, some customers are asking, can we increase the retention date to 30 days and what is the cost? So from this graph, as you can see, the Pinot server is pretty costly, similar like as the broker and also the zookeeper. But the cold storage, the HDFS itself, is actually very cheap compared to the server itself. So if we take the login search as an example, so instead of using 7 days data, we want to increase the retention to 30 days data. If we want to serving directly using Pinot server, we probably also need to increase the controller and zookeeper. So all the costing for this whole approach will be $30x. And we also notice we actually have this segments on the HDFS. So we thought about a new query path. Instead of reading the data from the Pinot broker, Pinot server, we can just read the segment from HDFS. Using this simple approach, the dollar will be X. We're also considering another approach is doing a hooding ingestion. So which means we're gonna do a hooding ingestion on HDFS and we have both segment data and hoodie data on HDFS. So since we are duplicating the ingestion process, so the dollar for that approach will be 2x. And I think some of you may have this question when you join this session to see like, we already have this Pinot connector, which gonna read the data from Pinot server directly. Then what's the reason of having this Pinot Datalake segment reader? So this is the reason. So if we want to increase the retention to 30 days, using the server itself is pretty costly, but if we use this new approach, it will be much, much cheaper. In the meantime, this approach, it can support the complex queries, like drawing queries and some UDFs. So this is because we read the segments as the raw file, and so that's why we can do this kind of complex queries on it. And this approach has another benefits compared to the hoodie ingestion is we don't need any duplicate copies. Based on these 3 reasons, we think we can have a new connector which can read the segment from HDFS directly. We call the catalog name is Pinot Datalake. So it's pretty straightforward of having a connector. So we're gonna read the metadata from Pinot metadata store. And once we get location, we can read the Pinot from HDFS directly. And this all information is provided by Pinot server. Then let's move to talk about this metadata store. So currently we plan to use the Pinot controller as the metadata store. There are a bunch of endpoints we need to use in this approach. The first one is /tables, /table name, /schema. So this endpoints, we can get the table schema like this. So you can see we have the schema name and also we have the column name, and for each column, we will see what kind of data type we're gonna have. The next one, we're gonna know like what's segments under this table name. So there's another endpoint called /segments /table name. So here is the response. You will see like how many segments files under this table. And the third one is we're gonna use /segments /table name /segment name /metadata to get a deep store location for this table segment. So it's gonna have a segment download URL here. I just want to point it out. So for all the segments, it will under the same path. So we don't need to run this endpoint for all the segments to get the download location. Instead, we just need to run it once and we can generate it the segments locations. That's basically how it works for the metadata store. So we also consider about some alternative metadata store solutions. The first one is have metadata store, the HMS. So this one is widely used in Uber. So the scalability and availability is assured. But there are also some cons, like firstly, we added some unnecessary dependency on HMS. And we need to do the compatibility evaluation with Pinot segments, because right now on Pinot end, they don't touch any code on leverage HMS to do anything. So we have to do the evaluation with the Pinot segment. The third one is, since we already have this information on Pinot controller, we're gonna have this duplicated metadata store. It's quite similar by using the Redis. The scalability, availability is assured, but we also need to think about how to make a data structure design on Redis to make sure it satisfies our use cases. Come to the end, we also have another internal tools which we can leverage on, but this one doesn't have segment level data. Meanwhile, if we want to use it in more generic way and publish to open source, if we are using the internal tools, it's going to be a little bit hard for the other peoples to reuse this connector. So we just skip this. Yeah, I think that's the basic, the thinking and the implementation on the metadata store ends. The next part, I want to talk about how we can read from the segment on Presto end. So the data on HDFS, the segment data on HDFS is a compressed file. So the way we read the segments information is we download this segment file to Presto disk and then decompress the file. And we can read the file row by row by using the Pinot provided functions and convert it to generic rows and then convert it to Presto page. And after finishing all this process, we just simply deleted the file. As you can see, like this reading process is pretty costly and it's not that fast. So just give you an example, like for a medium-sized table, right? We already have 6,000 plus segments. So it's gonna be 20 TB data for 30 days. If we load all these segments to our disk together and decompress it, read it, it's actually put a lot of pressure on Presto cluster. So to avoid that, we want to add this time range filtering as the first feature. So as you may notice in the table name, in the segment name, we have this table name and also the ingestion time. So for this example, this segment is ingested on May 6, 2024. There are also another column which is forced to have in each segment is called ingestion epical MS. So this the type for this is long and is milliseconds. So using these two informations, we can ask the user to provide a time range in the queries. And also use that information, we can eliminate some of the segments that we don't really need to read. So this is the example. We are asking the user to add this ingestion epical MS. And also, if they didn't do it, we will return a user error to say like it's missing data filtering. So in this way, we can read as less as segments as we need. And the second part is talk about like for 30 days data reading. As you guys may notice, like in the very beginning, I talk about this. So this is one of the main feature, like the customer request. So how we can do this? In Pinot server, there are some configurations as you can see here. There's two parts. One is called retention time value, and there's another called retention time unit. So this 7 days means how long it's gonna store in the Pinot server. And also there's another one called the deleted segments retention period. We can change it to 30 days. So what does this mean for the 30 days? So after 7 days of the ingestion time, it's the segment name is gonna change to retention until some date. And the location previously is under /table name. It will move one level up, gonna move to /deleted segments /table name. This is how it works. So the segment after 7 days, it's gonna move to this folder and it's gonna delete it until this date. So in our case, we can read this information from Pinot controller to get the initial location. And since the logic is exactly the same, we can use this logic to come up with the new location for the rest 23 days data. So then we can do a HDFS listing to get to know all the segments under this folder. So in this way, we can listing all the segments we need to read in the metadata read process. Yeah, I think this is basically how we gonna implement our connector in the first phase. I think we also thought about like some other improvements and what we can make it faster. So I think the first thing is the caching. So this segment is immutable. So we were thinking about we can add some widely used segments on the local cache. And the second thing is we want to do some optimizations. There are some min max column values in the metadata store. So we want to use this to do a further filtering to eliminate some not needed segments. Also, we thought about like in the ingestion part, we can also do some improvement as well. So right now we are reading the segment format directly from HDFS, but as you know, this is actually quite kind of like raw data, and we don't have too much optimizations over it, but we're considering like convert this segment to a Parquet format. As you guys know, like Parquet is a pretty widely used format in Presto end. and we want to see like if we can convert it to parquet format, then we probably can just do a lot of the optimizations over it. In the very end, I want to special thanks to the support from the Pinot team. So Ting Chen and Jenna, they are from the Pinot team in Uber. And I would say like this connector cannot success without their help. So Ting and Jenna also joined these sessions to answer any questions you guys may have related to Pinot end. So yeah, I think that's it for today's session, and we can move to the Q&A.